In this video, I'm going to show you how to make slope in Gdevelop. Let's get right into it. Okay, so let's get started. Now, slope, if you don't already know what it is, slope is like a hit flash game. I believe it's a hit flash game. It's on many flash game websites, but it's a game where a ball, a 3D ball, it rolls around a 3D space. And the thing that makes slope different from other 3D games is like you're using actual physics. Like it's a ball just rolling around all these different areas and it's using physics. Now the thing is, we're going to learn how to use this in Gdevelop because it is a 3D game. And let's get started first of all by adding the player object. The player object is a physics object that is a ball. Now the first thing we will want to do is add a new object here. And then we want to scroll down and put 3D model because Gdevelop now have 3D model support. So we want to click 3D model. And then we want to name this player. So we're going to name this player. And then the 3D model. Now you see we don't really have a 3D model for the ball yet. So what we're going to do is actually search up a 3D model and download it and import it. And if you don't know how to do this, I have a tutorial on it, but I'm going to show you how to do it real fast. It doesn't take that long. Now I'm going to search up Sketchfab. Sketchfab is a website where you can find many models. Some of them paid for, but many of them are free. So Sketchfab is a good website to find free 3D models. I'm going to search up slope ball. And here we have it. We have slope ball. And this is the ball, the 3D model of the ball that is used in the game Slope if you've ever played it. If you haven't, you should go check it out. So we're going to download it here. And we want to click download 3D model. It's important to note, make sure you download it as a .glb format. That right now at the moment is the only format that Gdevelop supports. So let's download it here. And once we click download, I'm going to save it on my desktop for now. Usually I don't save that much on my desktop, but I'm going to save it on here for now. And here we have it, slopeball.glb. And I'm going to go back into Gdevelop, and now let's choose a file. And I'm going to go into my files, go into desktop, and then go into slopeball.glb. And click OK. And now you should see I have my slopeball. And let's leave everything the same right now. The default size, everything is fine at the moment. So let's click apply. And let's drag it onto the scene. That's what we want to do. So as you can see, there's a problem already here that we have. The problem here, if I preview this, as you can see here, it's black and white here. But if I look on Sketchfab, which is where we got it from, it clearly has green on the model. So how do we get that green? Because the slope ball is green. So how do we actually make it look green? Now, there's a certain feature in Gdevelop, and it's called keep model material. Because certain 3D models, they have materials, which is like a picture that's mapped onto the sphere in this case. So we want to keep the model material. We don't want to just put no lighting effect. And it'll say make sure to keep lighting effect. We don't actually need to use this for this case. I'm going to click apply. And now if I hit preview, you're going to see something different. Now you're going to see that the ball is actually green. So that's what we want to do here. And another thing we want to do is we want to hit apply, not apply. We want to double click into the player, go into his behaviors, and then add a behavior. Now, behaviors, even though behaviors, all the behaviors that you see here are actually meant for 2D objects. But the thing is, we can easily take advantage of the 2D physics and still apply it to 3D objects. Because remember, the way that 3D objects work in Gdevelop, it's just still two dimensions, but with one extra dimension that works slightly differently. It has to be controlled differently. Now it's going to behaviors, and I'm going to scroll down to Physics Engine 2.0. And it's going to be a dynamic object. A dynamic physics object means that it will actually move around. Static objects, it will not move, and it cannot move. And kinematic objects, they also will not move, only if you put a force on them. But dynamic objects work how objects work in the real world. They move around always. They have gravity applied to them, and so on and so forth. We want the shape to be a circle. And let's hit apply. Now you're going to know something weird. You're going to know something very weird. So I'm going to hit preview. Well, you're not going to notice anything weird now. I didn't do this yet. But we need to add one more thing before you start noticing some problems first. Now we need to add a camera. So in order for us to have a 3D game, because Slope is third person, that means we need a camera outside the player. So let's add a new object. And we're going to scroll down. This is also going to be a 3D box, not a 3D model. And I'm going to name this camera. And here we have it. We have camera. And the sprite that we want to use, we have 6 sides or 6 faces. And all of these faces need to be a sprite. Now I'm going to go into here. Normally you would go into Piscal. Like I said, if you've seen my other tutorials, my Piscal is always broken. But all you have to do is create a 32 by 32x cube of any color you like. But in my case, I'm going to go to my files. I'm going to go to my pictures. I'm going to go into my game sprites and the sprites I use for my tutorials, and go into my blue cube right here. And in this case, we don't actually need to show all the faces. In reality, we only need to show the front face because that's what we see in the editor. Let's just not show any of these faces actually, just so you can see it. So we're not going to show any of these faces, but I will fill them in with the blue cube because Gdevelop, it's just better if you put everything in just in case you want to show the other faces. Now you'll see if I hit apply and drag it onto the scene, the only face that you can see is the front face. And the reason why this doesn't really matter is because we're not going to see the camera anyway. So that's what we're going to do here. Now that we have a camera, if I hit preview, of course you'll see nothing's going to happen. Nothing has changed in the least because we haven't actually programmed our camera to do anything. So how do we program our camera to actually look through this object, which is the camera's eyes? Now we need to download a free extension, of course. This is part of the Gdevelop officially supported extensions. Let's create or search for a new extension in the extensions tab. If you don't know how to get there, click the project manager, then click create or search for extensions. And I'm going to put first person, and it says first person 3D camera. And basically we're looking through the camera's eyes. Now I'm going to add a new event. We're going to go into our event editor, add a new event. Now we want this to always happen. Every time you want something to always happen, put no condition, and then you put add action. Go to other actions and scroll down till you see first person 3D camera. Then you want to put look through object eyes, and the camera we want to look through, well, the object we want to look through is the camera. So let's click OK. And now if I preview, you're going to see something a little different. You'll see that the ball is falling, but wait, what did we just see? Let me put this up so you can see it a little better. You'll see that the camera is looking through it. We're looking through the camera's eyes, which is good. But something strange is happening. You'll see that our ball, for some reason, is falling to the side. Even though clearly a little while ago it was just falling as it was supposed to be. Now, I have a tutorial on explaining how this works and just showing you some examples of how it's used. But to keep things simple, I just want to show you what I did in that tutorial. All I did was click into the camera and go into rotation of the X and then put -90. All I'm doing is basically rotating the camera. As you can see, I'm rotating the camera to look in a different way, to look at everything in a different type of way. And now when I preview, it actually follows how it's supposed to be. Now, of course, there are pros and cons to this. I explained it in my previous tutorial, my most recent tutorial besides this one. And you can click it. It should be in the top right corner right now, or you can go to my channel and watch it there. But basically all you need to know is this makes physics work as you expect them to work. Now, we want to make it so our camera follows the player. Or we want our camera to follow the player. And before we do this, we want to actually let's set up some ground first. Let's set up some ground. So let's add a new object. And let's go scroll down into 3D box. And let's name this 3D box ground. And then let's go into our faces. We want to show all the faces. And then for this, of course, you can get 32 by 32x cube. Once again, I'm going to go into my files and choose this black cube. And let's fill it in for all the face images. So I'm going to fill it in here. This shouldn't take long. And they're all filled in. Now let's go into the behaviors tab and add a behavior. And we want to also add the physics engine 2.0. And this is important because physics objects can only collide and actually interact physically in terms of a physics sense. Realistically, they can only naturally react with other physics objects. So if I put down a regular object like a regular sprite, it's not going to collide with that very well. It's not going to act like it's actually an object. Now, the ground, we want it to be static. That means it can't ever move. It will never move. It can't ever move. And we want to have a fixed rotation. And then we want it to, everything else can stay the same. In this case, everything else can stay the same. And let's hit apply. I'm going to drag this onto the scene. As you can see here, I'm going to drag it on. And if I now stretch it out, put my camera up here, If I stretch it out, let's put it down here actually. Now let's hit preview. And I should actually land on the platform. As you can see, I land on the platform correctly. And you'll see we're looking in a forward view. We're looking in a forward view. And this is great progress right now. Our ball actually has something to stand on. Now, how do we make it so the camera follows the player? So let's get started with that code. Now, the way that we make it so the camera always follows the player is actually quite easy. It's not that hard. So basically, we want to set certain positions to always be equal to a certain position of the player relatively. Now, I know what I said kind of didn't make any sense. Let me just show you. Now, the first thing we want to do is we want our Z position. Now, in terms of our scene, our Z position actually, in this case, will be controlling our left and right. And what do I mean by this? Look at this view. Look at my mouse cursor. Our Z position, if I add it up, like, it'll be going left or right. That's how it'll be going. And because that's one of the downsides, or for some people is a plus side, of using this method of turning the camera around. Our Y position will still be up and down, and our X position will actually be moving us forward and backwards. So, how do we want our X position to be? Now, we want our camera to always be spaced out from the ball, not all the way up on it. So let's add an action, and this is in the always. So we want to set the X position of camera. So click into camera, type in X position, and then once we go into X position, we want to set it equal to, and we're going to put player.x, and then we're going to put minus 558. Now, I know there's a super specific number. These are just numbers I tested. It doesn't matter what these numbers are. These are just numbers I tested that I found right. You can change these however much you want. And if I look into the scene, it's basically taking the player's X position and then making it go backwards by 558 pixels. That's all it's doing here. So it doesn't matter where it starts off. Let's preview. And now you'll see that our camera is more spaced out now. Now let's do the same thing but for the Y position. Now let's go add an action, click into camera, and let's type in Y position. And we want the Y position to always be equal to player.y, and we're going to put minus 90. We don't put plus. We want the camera to be slightly above the player. If we were to put plus, it would be slightly below. The way Gdevelop works, if we subtract from the Y, it goes up, and if we add to the Y, it goes down. So let's click OK. And now if I preview now, you can see now it actually follows it. Like when my ball was falling, if I preview this one more time, when my ball is falling, it's actually falling with it. It can be a little jittery sometimes. You can make it tween, but we're not going to go over that in this tutorial. It's not that bad here. And one more thing, we want the Z position. Remember what I told you, the Z position in this case is going to be our left and right. So we're going to add an action, click into player, and put Z. I'm going to type in Z. And then I'm going to scroll down until I see the Z. Let me see if I can find, I don't see the Z right now. Let me scroll down and we see Z. And it says Z elevation. Like I said, they expect it to be elevation. Normally in Gdevelop 3D, the Z controls the height of everything. But in this case, since we use our method, it doesn't. But we want the Z of the camera to always be equal to the player Z order, which means we put player and then dot, which signifies like a method or a class, as some call it, and Z. Player.z with the parentheses. And now we have our camera settings all set up. Now you can't really tell that it's following on the Z just yet. So let's make some controls so we can move like left and right, so we can move forward and backwards. So in slope, actually you automatically move forward. So in slope, we're going to just start by programming the side controls. So let's add a new event, and I'm going to right click this new event and put move events into a group. This is the way you keep your project organized. You don't have to do this actually, but I keep my projects organized like this. So side controls. Now the side controls are going to be the left and right arrow keys. So let's start by adding condition, other conditions, and then click keyboard, key pressed, and then put left key pressed. Left key pressed. So we're basically what we're saying, if left key pressed, what are we going to do? And the thing that we want to do, let's put it in our actions. So when left key is pressed, we want to go to the player, and then we want to go into the Z. And let me see if I can find it. It wasn't here last time. Okay, Z elevation. And then we're going to put subtract. We're going to put subtract 4. And let's click OK. And remember, our Z position is what's moving us left and right in this case. So now by preview, you're going to notice a problem when I move to the left. Let's move to the left. I'm moving to the left, which is fine, but you'll see that I'm not actually standing on anything. I'm standing on air. And we're going to fix that later, because that is the downside of us using this new method of 3D. Even though we have realistic Y physics, we no longer have realistic left and right physics, or I guess you would kind of say the X physics. That is no longer realistic. But everything is fine in terms of us moving to the left. Now next, what we want to do is move to the right. So I'm going to copy and paste this code. And I'm going to put, instead of if left key is pressed, I'm going to put if right key is pressed. And then for changing the Z position, I want to add instead. This is basically just common sense. We want to do the exact opposite. And if I preview, if I move to the right, I can move to the right. If I move to the left, I can move to the left. Now, how about moving forward? In Slope, Slope is a game where the player is always moving forward. The player is never stopping. The player is always moving in the forward direction. So how do we do this? Now, we have to remember that our object is a physics object. So we have to change forces. Well, we have to add forces to it a little bit differently. So let's add an action. And let's click into our player. And this is, remember, this is in the always action. So let's scroll down in our linear velocity X. Remember, this can get a little bit confusing, so pay close attention. Remember, our X value is what now moves us forward. Our X value is what moves us forward. So we want to set our linear velocity. We want to always add 1,000. That's what we want to do. And then let's just set it. Okay. And you're going to notice something. So let me stretch this out so it can be really long. Because if not, we're going to fall off quite quickly. Let's set it up to be like this long. Now, if I hit preview, you'll see our ball is just moving at lightning fast speeds. It's moving at lightning fast speeds. And there's a reason for that. Since we're always adding a linear velocity, we're adding it every frame, and there's no limit to how much that linear velocity can be. So that's why it's moving so fast. And that's why you can literally see it like jittering. It's moving really fast because of the velocity. Now, we want to limit that velocity, and we limit it by using a method that's called clamping. We use it by using a method that's called clamping. So clamping is basically, it sets a minimum and maximum value it sets a minimum and maximum limit that a value can have. So I'm going to copy and paste this change linear velocity on X, paste it, and let's put this. Instead of putting adding, of course, you never want to use add with clamp. You always want to put equal. Now, when we're using clamp, the speed in pixels change the linear velocity on X. So, of course, we're going to put clamp. We're going to put clamp and then put parentheses. Now, the first value, clamp is a function that takes in parameters. Now, the first parameter or value that we want to do is the object that the value that we're trying to limit. We're trying to limit the linear velocity. So we're going to put player, because we first have to access the player. Then we put dot physics. We're accessing the physics behavior that's on the player. And then we can finally access that linear velocity on X. If I go down, linear velocity on X. When you're dealing with physics objects, if you want to access a certain variable of it, you have to go through the player or the object first, then put the behavior, and then put the actual value that you want to access. And linear velocity X. Now that we have that value, that's the first parameter, we separate the parameters with a comma. So I put a comma here, and then I put 0. This is the minimum value. Our minimum value on our linear velocity to be is 0. And then I put another comma, and our last parameter or value is 1,000. That's the maximum it can be. So no matter what we do, the player's linear velocity will never go over 1,000. That's what clamping does. And if I preview now, you'll see it's actually moving correctly. I'm rolling. Don't worry about how the it's kind of clipping through the floor. We can handle that in another type of tutorial. All you have to really do is change the physics, not the physics, the hitbox on the physics object, but we don't really care about that right now. It works exactly fine. And as you can see, we actually roll off the edge of the platform, but we still don't roll off the sides. If I preview this again, we still don't roll off the sides, but we roll off the edge of it. So our next step now, since we've made our camera, we've made our player move forward and it's rolling, and it rolls naturally because of physics object. The next one we want to do is add the side fall. This is a problem that I said we were going to have a solution to on my previous video of using this new 3D method. So I'm going to add a new event and move this event into a group. This group is going to be called side fall, because that's what we're doing here. Make sure you always make your groups actually relevant. Now, the technique that we're going to be using here is what I call, and it's really not what I call, I didn't make this technique, this is just a common thing that's actually used in Gdevelop. It's going to be mask switching, or in this case, mask toggling. Now, what do I mean by mask toggling? Let's go into untitled scene, and let's go into our camera, not our camera, let's go into our ground. Now, if I go into the behavior, this is something specifically for physics objects only, so don't look for this, or don't think it works for non-physics objects. If I scroll down, you'll see I have two things down here, and you see layers, and you see masks. Now, layers and masks are quite similar, but we're going to be using mask toggling, because masks are what control whether or not your player can actually collide with the mask. Now, what do I mean by this? As you can see, this is what we have right here. Our layers go all the way up to 16. Let's ignore the layers. Let's just talk about the masks, because that's what we're going to be using. Our masks go all the way up to 1 and 16. The blue things are what is enabled. As you can see, layer 1 is enabled, mask 1 is enabled. And if I put player, if I go into the behaviors for player, you'll see it also has mask 1 enabled, and it also has mask 2 enabled. Now, you'll see something happen. If I get rid of mask 1, if I click it, which means it's disabled for the player, my player will no longer be able to collide with the ground. As you can see, I just fall right through it. Actually, it's a little jittery because it's trying to keep up with it. A little bit jittery, but we can make it tween it later. It's falling smoothly now. Okay, so as you can see, that's what masks do. So in order for us to be able to collide with the first mask of the ground, our player has to have our mask enabled. And the same thing for the ground and vice versa. If I go into the ground and disable mask 1 for the ground, the player will go through the ground still, because the mask is what controls the collision. Now, let's go into grounds. Let's go onto our ground and let me see. Let's enable this again. Behaviors, and let's enable the mask. So those are what masks do. Now, what we're going to be doing is, depending on our X position, not our X position, depending on our Z position. Because look at this. If I make the Z position go up to 100, you'll see that the ball is moving closer to the screen. If I put 1,000, it's really close to the screen. It looks bigger. So if I put 1, yeah, you'll see it gets bigger and gets closer to the screen. If I put a negative value, of course, it gets farther away from the screen, all the way until you can't see it. So basically, depending on our Z ranges, our Z positions, we want it to fall off. We want to disable the mask on the ground so it ignores it and falls off. So how do we do this? Now, we have to do it in a way that's flexible, because if we don't do it in a way that's flexible, we have to hard code values depending on the size, depending on the width, depending on the Z order of each platform. So I'm going to show you some code, and then it's all going to make sense in the end. I'm going to show you some code first. Now, in order for us to start doing this, we want to check this for all pieces of the ground. We want this code to apply to all pieces of the ground individually, not collectively. And what I mean by that, that means when one mask is shut down, we don't want all of the ground's masks to shut down. We want only that one specifically to shut down. So I'm going to show you this. So if we want to apply events to objects individually, all we have to do is go into this plus symbol here in the top right corner, and choose and add a new event, and then put for each object and this ground, and basically repeat for each instance of ground. This means they're applied individually to each instance. Now I'm going to go into our condition, add a condition, and I'm going to put, let me see, we're going to put events and control flow, and we're going to put or. Or what or does, it basically, if any of the conditions are true, even if one of them are true, then we want to do a certain action. And let's put the Z position. Now I'm going to let's actually make it so you can understand. I'm making a tutorial so you can understand. Let's debug this. We want to be able to see the Z position of the player at all times. So let's add a new object so we can debug and see what's actually happening. So let's add this text object, and I'm going to name this Z of player, and it's going to be a font size 30. Don't really care about all these details. I'm just going to put it right here. And I'm going to hit apply. We want this to always be able to be seen on the screen. So I'm going to go into my layers. If you don't see your layers, you can click this layer panel in the top right. And we're going to add a new layer. This layer is going to be called UI. And basically, the camera is not following the UI layer. So that means it'll always be on screen no matter what. And I'm going to click into this text and make sure that you click its layer and then put UI. And then you'll always be able to see it no matter what. Now what we want to do is go into our always, that means it's always happening, add an action, go to Z of player, and then modify the text. Now we want it to be equal to toString. We put toString because that's a function that makes that converts numbers, or even booleans. It converts numbers to a string value because that's the only way text objects use string values. And we're going to put toString round. We want to round the number. If not, we're going to have this super long decimal around the place. And we want to put round, and then we put player. The value we want to round is player.z. And remember, this is kind of the way the X works. So I'm going to click OK. And if I put preview now, you'll see when I move to the left, it goes up. When I move to the right, it goes up. And I'm going to make it so the thing is really long so you don't see me fall off, because I'm trying to explain a feature right now. We'll shorten this later. It's super long right now. Okay, this should be good enough. Now, we want to make it ranges. So in this case, it looks like when our player is about -50, that means it's a fall off. And then for here, it looks like when our player is about 150, it should fall off. I'll say about 150 if I touch that again. It should be about -50 here, fall off, and then 150 here. Now, we could hard code those values that if it's greater than or less than any of those values, it falls off, but that's not flexible. That means if I change the width or the depth, in this case, of the object, I'll have to rechange the code, and that's not flexible and that's not good. So how do we do this? Now you'll notice, let me preview again. You'll notice that the left edges of this platform are all based on the Z position of our object. But you'll see the right edge of the platform is based off our depth of the object. Like if I set this Z to -100, if I set it to -100 and then put my ball in here, now you'll see I fall off the platform about like 50 more than the Z. And the same goes for the depth as well. But you get the point. Basically, we need to make it go off of our Z and our depth to make it actually flexible. So what code do we want to do? Now, the first thing I'm going to actually do is put for this OR, we're going to go into add our subcondition for the OR. And then we're going to click into player. And then we're going to scroll down till we see our Z, which is elevation. Don't really worry about the elevation. I explained that earlier. But we want to put if our player, if our player Z position is less than ground.z. And remember what I said. The ground, when we fall off about 50 less than the value of the ground Z order, or I keep saying Z order, the ground Z position, we fall off at about 50 less than that value. So we're going to put ground.z -50. And let's say for this is our minimum limit. This is our left limit, falling off to the left. And same thing, falling off to the right. Falling off to the right. We want to put, I'm going to copy and paste this because we're going to use a similar thing. Double click into the next one. And we're going to put for the next one, if our ground is greater than, ground, instead of putting ground.z, remember our right limit is based on our depth of the ground, not our z. So we're going to put ground.depth, and then minus 200, and this should be pretty good. And the reason why I put minus 200 because, let me see, you see right here. Right now our depth is not that high. This works specifically if our depth is a decently high amount. If our depth is extremely little like this, it won't work exactly as planned. But luckily, we won't be using those type of objects. Oh, I didn't actually do the code yet. So now that we have our parameters, ground.depth minus 200, we're going to put enable our mask. So I'm going to click into ground, and you could do this for the player as well. But we're going to put enable mask. And the mask we want to, in this case, we want to actually disable it. So we put 1, and then instead of putting enable yes, we put enable no. And then we click preview. And you'll see I'll automatically fall through. I told you, the code is flexible only for the big platforms. For the smaller platforms, you could hard code the value. I would recommend for really skinny platforms, you could just hard code the value because skinny platforms work differently. But if I make this platform 500, let's say, 500 as depth, and if we want to center our platform on like in the middle of the player, whatever the depth is, you want to half that number and then inverse it. Give the inverse. Basically half of 200, half of 500 is 250, and then we put negative 250, and then it'll be centered. But if I hit play now, you'll see that I'm actually, if I go to the left edge, I fall off now. And if I go to the right edge, I fall off. And like I said, this works for thick platforms. If I set this to 1,000, and then I set this, you have to have it centered like this. We want to make sure our platforms are centered on the player. But if I put, it doesn't actually have to be centered, I just like the look of it. But I put negative 500, it's still flexible. If I fall off this edge, it's not just a hard-coded value. Now if I fall off this edge, then I start falling. And the same thing for the other edge. If I fall off this righter edge, okay, it didn't work exactly as I planned. It was a little bit too high. But there's certain ranges that you can go through. There's certain ranges. It's greater than ground dot depth. So yeah, this is what it is right here. So last time it was minus 200, and it's based on the depth, ground dot depth, and then for a bigger platform it would be probably minus 500 or something like that. But it's all based on the outer limit. This is not flexible as I saw. I might have made a little mistake here. But all you know is that the thicker the platform is, the higher this minus needs to be here. So let's set it to, and I have a more flexible way of doing it, I just can't cross my mind, but let's set the depth to 500 like we originally had it, and then this to negative 250. I know a flexible way to do it, but I'll probably just put it in the comment section or something below. Here. Okay. Now let's do the same thing, but for enabling the mask again. Because if we have to have a way of enabling it again. So let's put copy. And let's actually not copy and paste it. Let's add a new event here. And I'm going to put it to the side. And then I'm going to put, let's add a new condition. And we're going to go to the top right, add a new one. Add for each object. And of course we want to do this for the ground. Now this is basically going to be exactly the opposite of what we just did. Exactly the opposite. So basically instead of if player Z position is less, I'm going to copy and paste this. Instead of player Z position is less than, we're going to put if it's greater than ground.z minus 50. And instead of putting or, we're going to put and. Because in this case, we don't want to check or. We want to put if both of the conditions have to be true. So and ground.z plus 550. Ground.z plus 550. So I'm going to put if it's less than, I'm going to put player, I'm going to copy this, paste it. If it's less than ground.z, I'm going to click this, ground.z plus 250. Like I said, there's a more flexible way to do it. I could have sworn I just had it. I could have sworn I did this when I programmed it myself. But it just can't cross my mind right now. I'll probably post it in the comments like I said. So let's copy this and paste. Instead of putting disabling the mask, we want to enable the mask. So we're going to enable mask 1 for the ground. And you won't be able to see it right now. But just know and believe that we will actually collide with the ground now. We collide with the ground and we can fall off the ground. So that's good. That's the side fall problem fixed. And you can use this concept in your other games. Now we have the side fall. What else do we need for slope? Now in the game slope, we have obstacles that if you touch them, you instantly die. You instantly die when you touch these blocks. And that's a big part of slope. So let's start by adding a new object and then designing a level with this object. Okay, so let's start. Let's add a new object and we're going to scroll down and put 3D box. This 3D box is going to be called depth block. It's going to be called depth block. And the width, height, let's keep it the same for now. We can change that later if we want. We want to show all the faces. I'm not going to use the actual block from the game because I couldn't find it on Sketchfab. I'm not a 3D modeler myself. So let's choose a file. Like I said, once again, go to Piscal, create a 32 by 32x cube. I'm going to put a red cube since a lot of times red in games signifies something dangerous. And I'm going to put red cube for all of these. Red cube for all of the faces. Now I'm going to hit apply and I'm going to drag this onto the scene. Now our idea here is the same thing for the side fall. Our idea here, we have to control the side fall in a way that, we have to control the Z position of the player compared to the Z of the object in order for the game to be able to tell, okay, is it actually colliding with it? Because remember, the Z-axis or the left and right is what is the one that's being faked here. We're using an illusion for it. Now let's scroll up and you can see the angle of it a little bit more if you scroll up. But I'm gonna make this a little bit bigger. And okay, here we have it. And I'm going to click. We have the player thing on scene. I'm gonna make this bigger. I'm gonna make this a custom size of 200 by 200 by 200. Okay, so now that's bigger. We want to just collide with it, and when we collide with it, we die, of course. Let's double click into the depth block. Remember, since we're using physical objects, any object that we want to actually interact with, dynamically interact with, we have to make it a physical object. So let's go into, scroll down to see Physics Engine 2.0. And this is not going to be dynamic, it's also going to be static. Fixed rotation, going to be a box, and everything else can basically be the same. So we're going to hit apply. Now if I preview this now, you'll see that if I crash into the block, even though I'm not even touching it, well actually I'm not touching it right there, hold on. Let me make it so it's a little actually on the block. I actually stop at the block. And that's not good. We want it so when we touch the block, it kills us. Now I could do this. You would think just naturally, let's create a new event and then put it in a group. All the objects in this group will be called death because we're dealing with the death of our player here, which is very sad. But we're going to go into our player and we're going to put collision. Now this is how you would think common sense should work. Collision, if our player collides with death block, we want to just delete the player. Of course, you don't want death animation and stuff, but we're just doing a prototype. So you'll want to delete the player. And I mistaken put delete death block. We want to delete player. And I'm going to put this more on the ground so we can see it. It's kind of hard to tell exactly if it's on the ground or not. Okay. Now, normally you would think this is the way things should go. And if I collide with it, you would think, okay, everything's fine. The player died. But look at this. If I go to the side, remember our Z position is being faked. Even though I didn't even touch it there, I still died. Because remember, when we're moving forward and backwards, that's the Z position controlling that. And the Gdevelop does not account for that because since it's still actually a 2D engine, it's still dealing with 2 dimensions. We're just making our own dimension, if you know what I mean. We're making our very own dimension. Okay, so what do we do next? The next thing we want to do is do a similar thing. I'm going to click into this and click D, which will disable the code here. We're going to do something very similar to what we did with the side falling, just slightly different. We're going to do it slightly different. Now, we want to make it so, let's go click into add a new event below. We're going to right click and then put add new event below. Now, we want to click this. You want to click this lower one first and then click for each object. That'll make sure it spawns down here. And then we're putting for each instance of death block. We want this to repeat individually for each instance of death block. So I'm going to start off with OR because we're checking if either of 2 conditions are true. If any of these conditions are true, we want to disable the mask of death block so we can pass it. So other conditions, we're going to put events and control flow, and we're going to put OR. And this means now if either of the conditions are true, we'll be able to disable the mask. Now I'm going to click into player. I'm going to type in Z, and then we're going to go into Z. So if the Z, in this case, if the Z position of the player is less than death block, we're going to put death block dot Z. So basically what we're saying, if the Z position of the player is less than the death block Z position, and I'm going to put minus 50. And I'm basically going to put 2 periods here. Minus 50. And the reason why I put minus 50 is because just like I tested earlier, those are general ranges where it looks like the player is not in collision with the block on the left side. Of course, you can test these and change them yourself, but I'm just using these values. Now I'm going to put, now for this, copy and paste it. If it's a greater than, for the right side collision, if the Z position of the player is greater than death block dot Z, death block dot Z plus. Now, first we're starting off with the death block dot Z. If it's greater than death block dot Z, and death block dot Z is equal to 0 right now. So if I put plus death block, I'm gonna put parentheses because we're gonna use a little bit of order operations here. Death block dot death block dot death of it, and then we're going to put outside of it plus 50. The parentheses might not have even been able to be needed. I think that was completely unnecessary. So not do unnecessary stuff like that. So what we're saying is, if the player's Z position is greater than the death block Z position plus the death block's depth, the thickness of it, and then the death block's depth plus 50. If it's greater than all of that, it can go. You can collide with it. And the reason why I did it like this, I've tested this for sure, is a very flexible way of doing the collisions. A very, very, very flexible way of doing the collisions. Now, let's go into, click OK. And now we're going to put, instead of enable, we're going to disable the mask for death block. So I'm going to click death block, and then I'm going to put enable mask. We're going to put mask 1 and put enable no. We're disabling it. Now if you see this, if I go past it, I should be able to go past it now. Okay, that's good. Now you think we should be done, we can just do a similar thing. And we are almost done, but not quite. Now we want to get code that enables the death block's mask. We want to get code that enables it. Let's go. So let's going to add a new event below, and we want to start off with repeat for each one. So click into the bottom one, put for each object, and repeat for each object of death block. And we're going to start by, we're going to be doing the exact opposite. So if the Z position of death block, I'm going to copy and paste this first one. If the Z position of death block is greater than death block dot Z minus 50, and then we're going to once again put and events and control flow, and we're going to put this one right here. We're going to get this condition, copy it, and paste it. And if it's less than death block dot Z plus 50, all of that, we want to disable the mask. We'll enable the mask actually. And we're going to put copy and paste, and we're going to put enable the mask yes. And I'm going to hit preview. Now I can actually die to it. Well, I didn't die to it. I forgot. I have to make it so when you collide with the mask, that you actually die from it. So we're going to program that one a little bit later because I want to show you something very soon. Now you're going to see we're going to run into some problems. And the only way we can showcase these problems is by making a sort of level that you kind of expect a player to make. So let's spend a little bit of time designing a level here. I'm going to just design a simple level where I'm going to copy this and paste this, duplicate it. I'm going to design a simple level where you go across a slope, like click it, we go across a slope. I'm having trouble clicking it here. Okay, you go across a slope. I'm going to make this slope shorter, much shorter than this. I'm going to make a level where you go across a slope, and then you land on another platform. I'm going to duplicate this. You land on another platform that's much thicker than this. We're going to set the depth to equal to 1000. And let's set the Z to be equal to 200, well, negative 500. I'll keep it centered. So now we have this object right here, and let's design a level using the thickness of this. So I can see our depth is 1000. We're going to set this player is equal to the Z position of this one is equal to negative 100. Well, not negative 100. Let's equal to 100. Maybe not even 100. Let's just set it equal to. We can keep it right there. I'll say that's fine. Okay. Let's zoom in so we can actually kind of see what's happening here. And we're just going to design a little level. Let's make this one really long. And if you want to skip past this part, you can. But I want to showcase something, a problem that you may run into. Now with this platform here, let's make it a little bit longer. Okay. Now this platform here, we want to start off with a block in the middle. And I recommend that you recreate this along with me, so you can also see the problem that is about to arise. And I'm going to duplicate this death block, duplicate again, and I'm going to set it to one of these to like negative 400. And you'll see this block is kind of now on the back of the platform. And then I'm not going to have everything perfect. Some things are going to look a little bit janky. And then this other block is going to be like equal to about 300 or 400. I'll say 200. So now this block is in the front. We got a block in the back. We got a block in the front, block in the back. And we're going to see what problem we are running into. So let's preview the scene and let's see. I'm just moving this back a little bit more. Let's see what happens now with this new problem that's going to arise. So if I hit preview now, so I start the level, I go up this ramp, and I fall down. I go past this block, everything's fine. I go behind it, and you'll think everything is completely fine. I think everything is completely fine. So let's see what happens here. And I go past it. If I go past this block, go past it here, I fall into it. I crash into that block. And actually it seemed like everything's working fine. I thought something was actually going to go wrong. I thought something was really going to go wrong, but actually everything is going completely fine. Okay, so everything's going fine. So now it's time to make it so our player actually dies when we reach a certain, like when we touch it. Now you would think that we should put it in here for enabling the mask, that we should delete the player. And let's see what happens if we do that. So I'm going to go into enable the mask. I'm going to go into player. I forgot, we can't put it in this one because we have to check if the player is actually doing this and is in collision with the player. So I'm going to copy this condition. Copy this. And I'm going to paste it. And I'm going to put, okay, all this stuff is true. And then I'm going to put and. Well, we don't have to put and again because and this condition is true. We're going to put player if player is in collision with def block. We want to, instead of enabling the mask, I'm going to delete this. I'm going to put add action, and we're going to delete the player, which is basically killing the player. I'm going to hit preview, and let's see what happens now. Let's see if any problems arise, because when I was testing this out on my own, I was running into so many problems. I'm just trying to make sure the viewers don't run into those same problems. Okay, everything seems to be 100% fine. Everything is 100% fine at the moment. I'm going to add one more block because I'm so suspicious that everything is actually working exactly as I planned. This is not usual in programming. Everything is actually working as I planned. And I'm just going to set this one right here and see if we run into any problems. See if we run into any problems. Okay, if I crash to that, I die. So, seems like we're running into no problems. No problems at all. So, one more thing. We have a problem that we need to fix. And the problem that we need to fix is this ground code not being flexible. Our side fall, as you can see, if I go and show you this right here, if I can fall off that, so I'm not going to do that. But for this thicker platform, remember I told you it's not flexible for those. So I can see I'm walking on air, and then I fall off of it. So what do we need to do here so it's actually flexible for all types? So I found the issue here. So the issue here is that we're going to basically use the same code that we use here with this def block, but instead of using the def block, we're going to use the ground block in order so we can actually fall off of the player. So for this one that says delete player, click into this right here, the value to compare, copy this using Control C, and we're going to go into ground.def. So we're going to go into this one where it disables the mask, and we're going to put, instead of def block.z, we're going to put ground.z. Going to put ground.z. Instead of putting def block.def, I'm going to put ground.def, and then plus 50. And let's preview this, and let's see what happens now. I fall off here. That's fine. We already knew that worked. So let's go into this bigger platform, and if we fall off there, that means we know everything worked. So let's fall off here, and it works. And that's how you get a flexible code for the ground. It was right in my face all along. I basically already programmed it. I just didn't use it on everything I needed to. But that is how you make slope in Gdevelop. If you enjoy videos like this, please comment down below. Please like, subscribe, and hit the notification bell so you never miss out on any of my new Gdevelop tutorials. There's lots of things coming up. Make sure any tutorials you want to see in the future, make sure you comment those down below as well. I'm happy to answer any questions you all have, and I'm also happy to see what tutorials you will all like to see in the future. Once again, I want to thank everyone here for watching, and I'll see you in the next tutorial. See ya.